Number 33, we need to find out the current in each of these three resistors, 4 ohm, 4 ohm, and then this is 6 ohm. And then we have two batteries, 4 volt and 2 volt, connected in this fashion. The special thing is this wire. What do we do about this wire which is in parallel with 4 ohm? How is it affecting the flow of the current in this 4 ohm? Rest of the things are simple. These two batteries are connected, not connected in series, so in a reverse order, not plus minus and plus minus. So for the battery part, what is happening is the effective EMF of these two batteries is going to be 4 volt minus 2 volt and in this direction. It typically, you can think of this higher 4 volt battery as a charger which is charging this other battery. How do you connect a charger to a battery to charge it? You connect positive to positive and negative to negative, and that's how it starts charging. So the 2 volt, out of this 4 volt, 2 volt will appear on that battery which it is charging, and the rest of will be there in this external circuit. So anyway, it's a simple thing. I'm not going to go into details of it. It's 2 volt here. What happens when you connect a 4 ohm resistor with a 0 ohm resistor in parallel? You can think it of two ways. One way you can think of it is that this 4 ohm and 0 ohm are in parallel, so the equivalent resistance is R equivalent is equal to R1 into R2, 4 into 0 divided by 4 plus 0, which is 0. And what is a 0 ohm resistor? A 0 ohm resistor is simply a wire. Okay. So what we can do is we can replace these two resistors with a simple wire between these 2 points, something like this. And in that case, it's easy to find the current through this whole circuit. 4 and 6 are in series, so the current through this whole circuit is 2 volt battery divided by 4 plus 6 ohm resistor, 2 divided by 10 or 0.2 amps of current. So that is the part 1 of this question. The current through this 4 ohm and the 6 ohm is 0.2 amps. Now, what is the current? Is there any current flowing in this 4 ohm? The current comes from here, and current always find a path of the least resistance. If there is a higher resistance, it will not flow in the current. And if this is a 0 ohm resistor, then all the current will flow through this. There is no current flowing through this. We can also understand it with this. Mentally imagine the point A and point B. The voltage across point A and point B is 0 volt. According to the same is the voltage across, if we follow this branch, then also the voltage across path A and B is also 0 ohm. So from point B and point A and point B voltage between these two paths, we have voltage V equal to 0. And if we follow this path, and let us say there is a current I flowing through it, then I multiplied by 4, that is also equal to 0. That means current I. That is only possible when there is no current flowing through this. Only then, if there is any current flowing through this, then there will be some voltage difference here, which contradicts the fact that there is no voltage difference between A and B because it's a simple wire. So we conclude that there is no current flowing into the 4 ohm.